What if the sun suddenly disappeared? In exactly 8 minutes and 20 seconds, you would realize the sun has vanished, but you'd already be dead long before you figured out why. Today, we're running the most terrifying simulation in physics. What happens when 99.86% of our solar system's mass just disappears? Welcome to MKT Techy, where we explore the science that shapes our universe. We're going to walk through every single second of what would happen if the sun suddenly blinked out of existence. And trust me, it's way worse than just losing daylight. Make sure to hit that subscribe button, because we're about to break the laws of physics. Theoretically. First, let's establish what we're dealing with. The sun isn't just a giant light bulb in the sky. It's a massive fusion reactor containing 99.86% of all the mass in our solar system. That's 1.989 times 10 to the 30 kilograms, or about 333,000 times the mass of Earth. It's burning 600 million tons of hydrogen every single second, releasing energy that takes 8 minutes and 20 seconds to reach Earth traveling at the speed of light. Now, for this thought experiment, we're going to violate every law of thermodynamics and just make it disappear. Instantly. No explosion, no supernova, just gone. So let's start the clock. 0 seconds, the sun disappears. But here's the mind-bending part. Nobody on Earth knows yet. Not you, not me, not a single satellite or telescope. Why? Because information, including light and gravity, can't travel faster than the speed of light. Right now, the last light the sun ever produced is still racing toward us at 300,000 kilometers per second. For these precious 8 minutes, life on Earth continues normally. People are having breakfast, going to work, completely unaware that they're living on borrowed time. The sky is still blue, the sun is still shining, and everything seems fine. But in space, something catastrophic has already begun. See, gravity doesn't just disappear instantly either. According to Einstein's general relativity, gravitational changes propagate at the speed of light. So Earth is still orbiting nothing. We're still held in an orbit around a sun that no longer exists. But that's about to change. 8 minutes and 20 seconds. The last photon from the sun reaches Earth, and then darkness. Complete, utter darkness. But it's not nighttime. There is no nighttime anymore. The moon is gone from the sky, too, because it was only ever reflecting sunlight. For the first time in human history, you'd see the stars from every part of Earth at the same time. Billions of them, clearer than ever because there's no light pollution anymore. There's no light at all. At exactly the same moment, Earth stops orbiting. We're now traveling through space at 30 kilometers per second, about 67,000 miles per hour, in whatever direction we were headed at that exact instant. We've become a rogue planet hurtling through the cosmic void. And we're not alone. Every planet, asteroid, and comet in the solar system is doing the same thing. The entire solar system just scattered like pool balls after a break. Now comes the cold. Without the sun's heat, Earth's average temperature starts plummeting. But here's something most people get wrong. It doesn't happen instantly. Earth's atmosphere and oceans are actually pretty good at holding heat. Think of them like a giant insulated thermos. Within the first week, average temperatures would drop to around 0 degrees Fahrenheit or minus 18 degrees Celsius. Cold but survivable with heating. But here's the real problem. Power. About 10% of the world's electricity comes directly from solar panels. Gone instantly, but more importantly, the weather stops. No sunlight means no evaporation. No evaporation means no rain. Wind patterns driven by uneven heating collapse within days. Hydroelectric power, which provides 16% of global electricity, starts failing as rivers freeze and water flow stops. Within 2 weeks, most fossil fuel and nuclear power plants would shut down. Why? Because they need water for cooling, and all the water is freezing solid. By the end of the first month, average surface temperatures on Earth would hit negative 100 degrees Fahrenheit or negative 73 degrees Celsius. The oceans, which cover 71% of Earth's surface, would start freezing from the top down. But here's a fascinating survival fact. The oceans wouldn't freeze completely. At least not for thousands of years. The top layer would form a thick ice sheet, maybe 10 to 20 feet thick. But underneath? Liquid water would remain, kept warm by geothermal heat from Earth's core. Within hours of darkness, every plant on Earth stops photosynthesis. Within weeks, most plants are dead. The entire food chain collapses from the bottom up. Herbivores die first, then carnivores, then scavengers. Humans. We'd have maybe 3 months before food supplies run out. Even with stored food, the cold would make survival nearly impossible without massive underground infrastructure. Here's where it gets truly alien. After about a year, temperatures on Earth's surface would stabilize around negative 400 degrees Fahrenheit or negative 240 degrees Celsius. At these temperatures, something incredible happens. The atmosphere begins to freeze. First, water vapor turns to ice. We already knew that. But then carbon dioxide freezes out at negative 109 degrees Fahrenheit. And finally, at these extreme temperatures, even nitrogen and oxygen begin to condense. The air literally falls as snow. Earth would be covered in layers of frozen atmosphere, nitrogen ice, oxygen ice, creating a blanket about 30 feet thick across the entire planet. But here's the silver lining, and I use that term loosely. Deep underground, near geothermal vents and hot springs, life could theoretically survive. Remember, Earth's core is still molten, heated by radioactive decay that has nothing to do with the sun. We're talking about places like Iceland's geothermal areas, Yellowstone's hydrothermal features, or deep ocean volcanic vents. With enough preparation, nuclear power, hydroponics, artificial lighting, small pockets of humanity might survive. We're talking thousands of people, not billions. Fast forward 1 million years. Earth is now a dark frozen sphere drifting through interstellar space. Surface temperature, negative 400 degrees Fahrenheit. No atmosphere you can breathe. But deep in the oceans, protected by miles of ice, something remarkable continues. Life around deep-sea hydrothermal vents, those volcanic cracks in the ocean floor, could keep going. These ecosystems never depended on sunlight anyway. They run on chemosynthesis, converting chemicals from Earth's interior into energy. Tube worms, extremophile bacteria, unique fish species, they'd all survive, completely unaware that the sun ever existed. Earth would become a wandering oasis of deep-sea life, traveling through the galaxy at 67,000 miles per hour. Now let's address the elephant in the room. Can the sun actually disappear? Number: absolutely not. This violates the law of conservation of mass and energy. Matter and energy can't just cease to exist. The closest realistic scenario would be if the sun instantly became a black hole. But even then, Earth would keep orbiting, just in permanent darkness. The gravitational pull would remain the same. What about solar flares or the sun dying naturally? That's a different video, but here's the short answer. Our sun is about 4.6 billion years old and has about 5 billion years left before it becomes a red giant. We've got time. So, what have we learned? If the sun disappeared, we'd have 8 minutes of normal life, followed by instant darkness and the beginning of a catastrophic freeze. Within months, surface life would be extinct. But deep underground and in the oceans, life, including potentially humans, could survive indefinitely. 8 minutes 20 seconds, until we notice 1 week, temperature drops below freezing 1 month. Oceans start freezing 1 year. Atmosphere begins to freeze. Forever. Deep sea life continues. The scariest part? This thought experiment shows us just how dependent we are on our star. Every breath you take, every bite of food, every degree of warmth, it all traces back to nuclear fusion happening 93 million miles away. So maybe appreciate that sunrise tomorrow morning, because in the grand cosmic scale, we're living in a razor-thin habitable zone around an average star, in an average galaxy, and the chances of everything being just right? Astronomical. If you enjoyed diving into this cosmic nightmare, hit that subscribe button and turn on notifications. We post new space, science, and technology videos every week. Drop a comment below. Would you try to survive underground, or would you spend those last few weeks above ground? I want to hear your survival strategy. Thanks for watching MKT Techy, and remember, the universe is both beautiful and terrifying.